Hello everyone and welcome to this my video on parallel and perpendicular lines. Or is it perpendicular and parallel lines? Does the order matter? Who knows? My name is Darren from Maths Guru. Thank you very much for watching. Yes, Maths Guru, spelt horribly wrong, basically is there to support you. It's got videos and downloadable notes and it's absolutely free to sign up. So if you head over there, hopefully you will find it useful. Now, my name is Darren, and I think I just said that, from Maths Guru. Yes. Can you do me a favour and subscribe? If you've already heard me say this 1,000 times and you haven't subscribed, please subscribe. At the end of the day, I do get very, very excited when YouTube tell me how many extra people have watched. And if that number goes higher than 3, I run around my room. It's crazy that I get that excited. Why? Well, who watches maths videos? No one watches maths videos. At the end of the day, I'm generally sitting here talking to myself. And so when you click subscribe, and very, very small matter for you to click subscribe, it really does mean the world to me. So thank you very much in advance if you could. Now, what am I going to work through in this video? Well, do we understand what it means to be parallel and perpendicular? All right, how to find gradients of parallel and perpendicular lines, or how they're related, and be able to find gradients. We must be sick to death of gradients by now, because that's what we've been dealing with left, right, and centre. Although in the last lesson, which was awesome, by the way, we did, what did we do? Midpoint of lines and lengths of lines. That was pretty funky and very real world. Maybe. All right, so, but we're going to go back. We're going to talk once again about gradients and intercepts and vertical lines and horizontal lines and etc., etc., etc. But just remember that for everything you do, y equals mx plus c. Very, very important, he says. All right, so what do you notice about the lines and their equations here? All right, are they parallel? No, because in a previous lesson, we knew they were not parallel because we found out that we had to have the value in front of the x the same. So in this situation, they are very much not the same. One is a 2, so the gradient of the first one is 2. The second one is minus a half. All right, they're definitely not parallel. Anything else we can tell about them? Different colors, maybe. Again, very important to notice that we can only compare gradients when they're both y equals. If they're not y equals, you can't compare the gradients. It's a huge trick. All right, okay, well, is there another set of lines we can look at? Oh, yeah. What about these lines? Y equals 3x minus 1. Well, they're obviously not parallel because, once again, what do we notice? Their gradients are not the same. One of them has a gradient equals 3, and the other one has a gradient equals minus 1/3. Nope, they don't seem to be the same in any way, shape, or form. So, oh, hold on a moment. What you guys didn't know, because hopefully I have tricked you, is that these lines are actually perpendicular. Now, perpendicular lines are basically two lines that will cross at right angles to each other. So I now know that there is a right angle in there and there is a right angle in there. So that's awesome. But would there be a way of knowing that just by looking at their equations? Well, this one here had a gradient equals to 2, which I'm going to write as 2 on 1. And this one here had a gradient of minus 1 on 2. Hold on. This one here had a gradient of 3, which I'm going to write as 3 on 1. And this one here had a gradient of minus 1 on 3. And hopefully you've now seen the trick, because yes, actually there is a link between the two of them. Because what we can do is, if I know the gradient of one line, the gradient of its perpendicular, the one that crosses at right angles, we basically flip the fraction. And if it's a positive, we make it a negative. And if it's a negative, we make it a positive. The world goes crazy. Now, let's just check the next one. 3 on 1 became 1 on 3. Was positive, became negative. Now, one of the big things you guys need to realize, and please, 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 is that although the gradients change, yes? Sorry, try that one again. The gradients change, as do the intercepts, right? What we notice is here, the y-intercept of that was minus 2. The y-intercept of that is 3. The y-intercept of that one is 4. The y-intercept of that one is minus 1. They are very, very different. That's going to become massively important in a little bit, because lots of people think that when lines cross, we just change the gradients and we don't worry about the intercept, but we do. So there is a shortcut to be able to do this. And as said, if I told you that a line had a gradient of 4, I'd write it on 4 on 1. So I know the gradient of the perpendicular, and I'm going to do the little right angle single there, is equal to, or swap it over to 1 on 4. That was plus make it minus ka-ching. So that's the gradient of the perpendicular. What about another one? What about if I had a gradient of minus 2/3? Well, the gradient of the line that's perpendicular to that would be equal to 3 on 2. So I swapped the fraction, or I reciprocated it. It was a minus. I make it a plus. Very, 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 very important. And again, as I say here, please guys realize